So, in the context of a volcano project, as you may know in Spanish, is Volcanología Canaria Submarina, that is a submarine volcanology of the Canary Island. So, and for sure, thank you so much for the team, because this is not a work just one person, it's a work of a lot of multidisciplinary persons that are working together in this project. So the main objective of the Volcano project is to improve the scientific knowledge of this in the area of the physical, chemical, biological, and geological processes associated with submarine volcanic and hydrothermal process in the Canary Island. So this is important not only to do science, but also to do advice to the administration and to the responsible of the crisis, the submarine crisis. You have to touch. Entendido. Yeah. Yeah. Okay, entendido. Okay. So here is a map of the several submarine volcano and superior volcano that we were monitoring the last 10 years. The first one is the Medio submarine volcano that is between the island of Tenerife and Gran Canaria. It's a submarine volcano that is in the depth of more than 2,200 meter depth. It's a building of around 6,100 meter high, and well, you will see later. The other one is the Henry submarine Simons, and for sure Tagoro submarine volcano that started in 2011, and also the Cumbre Vieja volcano in La Palma. So we are shortly speak a little bit about all of them. Then, how you see here, we were doing a really intense monitoring from more than 12 years and more than 32 oceanographic cruises. I don't know if you know how difficult it is to arrange an oceanographic vessel. It costs a lot. So to carry more than 32 oceanographic cruises, this is a really big effort. We have to find funding for everything, everywhere around, and it's really difficult to maintain a really time series, a long time series. Well, also, not only we use our vessel, that our institution, the Spanish Institute of Oceanography, have several vessels. Actually, these two, Ángeles Alvariño and Ramón Margalef, they are quite big vessels for around 60 meter long length. But we are building a new one that will be ready in 2024. That is called Odón de Buen. It's going to be the biggest ship in Spain from the oceanographic point of view, and we are going to use it also in the Canary Island. But also we've got an ROV that can reach 2,000 meters in depth, and also sometimes a submarine that maybe you visit there in Radazul. So we were using also in La Palma, if you can see there. So as you can see, there's a lot of logistic that we were using in order to monitoring this submarine volcano in the Canary Island. Also, from the physical and chemical point of view, we use several instruments like the Rosette in order to take water samples, in situ water samples, temperature, conductivity, pH, oxygen, turbidity, fluorescence, everywhere. But also from the chemical point of view, we recover dissolved oxygen, DK, inorganic nutrient, pH, alkalinity, TIC, POC, heavy metals, and from the biological point of view, phytoplankton, zooplankton, bacteria, everything. As you can see, all the different areas are completely measured in the whole water column. That is really important. But also we are doing a really big effort in order to do an innovation, technology innovation in Volcano process, in Volcano project. We were using and completely design a new instrument for our ROV in order to measure the hydrothermal vent and the submarine volcano. This is a new hydraulic syringe. This is the version 2. We are really proud of that. In order to measure the hydrothermal fluid sample, but also named Cachimba. You know, Cachimba is a word, Canary word, that is like a smoke pipe. No, why? Because we wanted to measure also the vertical velocity of the diffuse flow of the hydrothermal vent. And later, another instrument that are having a really nice result are our minion. It's a minion because the little minion, no, yellow, so we put this name. And it's also a sensorized bulb for monitoring this diffuse output. So all these instruments were completely designed by us and were tested by us in our cruises. So let's talk about the submarine volcano Tagoro. In order to speak about the submarine Tagoro, we have to go back in time till July 2011, where the island of Hierro started showing more than 15 earthquake, and finally the earth crust broken on 1.8 kilometers south of the island of El Hierro in the village of La Restinga, starting the magmatic activity. You can see here the perturbation of this submarine volcano with a lot of decoloration processes in the water column, and the perturbation were also could be monitored by satellite. You can see here the huge plume that we are transporting with the current, and also transported with several mesoscale structure like cyclonic and anticyclonic eddies. So the perturbation was not only in the south part of the island of El Hierro, but also we are transporting hundreds of kilometers far away, and also perturbing the east, the west part of the island, and also the north part of the island, and even they touch sometimes some occasion another island like La Gomera. And you can see here in one of the main in research, the island of El Hierro, the marine ecosystem of the island of El Hierro become to a natural laboratory. Why? Because in this area, for 6 months, they converge the three processes that are the main stress of the climate change. That is the increase of temperature, the ocean acidification, and the desoxygenation process. They were working all together in the same place. You can see here the climate change model predict that for the next century is going to be an increase of temperature of about 0.6 degrees. And could you tell me how was the increase of temperature in the submarine volcano Tagoro in the whole color water? So more than 18.8 degrees. So that was really, for this reason, you can see the face of our colleague. No? And the ocean acidification, so the model predicts also a reduction of the pH of around 0.1, 0.3 in the next century. But in the water, we were finding reduction of the pH of around 3 units. That is a lot. But also the sulfur was around 50 and 100 micromole, or the CT was even more than 400% of the ion. The ion was 4 million times higher than the normal condition. And the PCO2 that in normal condition are around 380 micromole in the water column, they were finding more than 300,000 micromole, so that was big, no? And also the desoxygenation processes that in the normal area is around 0.7, it was more than 97%, so that was a big problem, no? As you can see in the natural laboratory, so more of the dead that weren't fish that weren't dead in the area is because of this, because there was no oxygen at all in the water column. But also this was not only catastrophic things, but we were finding new kind of bacteria worldwide that only we saw in this in the Hierro Island. There's Thiolaba veneris, and is published in this paper. But also 6 months, the submarine volcano was emitting this huge quantity of magma, gases, heat, and producing a catastrophe in the marine ecosystem. But later, from March 2012, they became into a new hydrothermal system, just releasing heat, gases, and nutrient, and enrichment of iron, producing recolorization process in a really fast rate. So right now, 12 years later of this crisis, right now the submarine volcano marine ecosystem is even better than before the submarine volcano. So that is the beautiful thing of the nature. No? So here is also the injection of nutrients that is really big. And this is the form that has the building. Welcome. That is a building of 300 meters, 1 kilometer of diameter, more than 14 secondary craters, and the main crater is just 88 meters below the sea level, so only 88 meters to have another island in the archipelago. No? And the main crater that is the more active is around 127 meters below the sea level. Well, with all this information about all this period of time, we can later build this kind of geomorphological map that is Vasquez is here, and they will say everything about that. But also the physicochemical anomaly are still present in the area. This is the main crater. You can see here our deployment completely clean, and this is the way that we recover, in order to see how strong are the perturbation over there. So you can see here that still today is more than 2.5 degrees of anomaly. Salinity is -1, and the pH is also -1.25 unit. But that was a little bit, I wanted to send you a question and say, this is the monitoring that we were doing during the whole year. No, this is the pH from all this transit. No? So this is south, this is north, this is south, this is north. So we move from south to north, and there's no perturbation, and we arrive to this area, that is where this main crater, the two main craters, we start the anomaly. This is the perturbation of pH. So it's constant in 2014, 2015, till now. No? But in 2020, it's happened something completely different. We were there, and we saw that the physicochemical anomaly in the submarine volcano Tagoro were out of the normal condition. We didn't register this perturbation in all the 10 years, so something happened. So this day we write a report for the PEVOLCA. PEVOLCA is the organization that is the plan for emergency of the Canary Islands. And on the 23rd of December 2020 at 7. Okay, so we send a report that something is going on. And a few hours later, this is in Spanish because it's a media press, and they say that a few hours later, you can see here at night, it started a news run of more than 280 earthquake in the island of La Palma. No? So there is some connection, I just say. And now, Cumbre Vieja volcano. That was in 2021. That a new volcano appeared in the island of La Palma, and also they've got a repercussion of perturbation in the sea. So for this reason, we were there. So we were there for more than 88 days, evaluating the underwater volcanic processes and the impact of the lava flow over La Palma marine ecosystem, with three main objectives. The first one was to conduct the physiographic, morphological, and structural characterization of the ocean floor linked to the southwest eruption of La Palma, and the second one was to investigate also the physical, chemical, and biogeochemical property in the whole water column, and finally also to assess the impact of the eruptive process on plankton and benthonic community. So you can see the images are really impressive. The lava reached finally the ocean on the 28th of September. Yes, you can see here all our work in our ship in order to monitoring this event 24 hours per day, 7 days per week during all these 88 days. This is a perturbation. The lava delta this is the surface area, but also the lava perturbation was going down the slope to more than 370 meters depth and more than 2 kilometers far away from the original coast. And you can see here our ROV taking samples at 300 meter depth. You can see here all the nice new pillow lavas that were formed in the area, and this geological construction were amazing. Also, there was a possibility for some person that can see here, Maria Jose Blanco, I have already seen you over there. She was one of the main person that were working in the PEVOLCA, and she was the opportunity also to go into the submarine and to see all these structures by her own eyes. So the perturbation in the water column was extremely high, not only in the surface, that this is really important, that all the paper, all the manuscripts that you can see in the literature say that the perturbation is also in surface, but you can see here that the perturbation we were registered perturbation in all the physical chemical parameters in more than 300 meter depth. Sorry. And also, Alba will talk about that especially, so I'm not going to go into that, but in La Palma, 5 minutes, okay. In La Palma was a special upwelling event that for several conditions, the ashes and the hydroclasticity, they didn't become a bloom, a phytoplankton bloom, conversely, that other manuscript in the literature, published in Science in Hawaii. So, and you can see that here there is different conditions and different processes with the same upwelling system. Alba will talk about that. If we move on a little bit and go to a medium submarine volcano between Tenerife and Gran Canaria, this volcano, you can see here that it's beautiful, right? This is the main crater, it's 2,000 meter depth, and we were observing this for the first time 2 years ago, something like that, because they was too deep and our instrumentation couldn't reach this depth. But finally, we find all this instrumentation in order to measurement for the first time if there is some physical chemical anomaly for this submarine volcano. And we also take some rock samples from the different points, and you can see here that we extract several modified rocks that could indicate some hydrothermal activity, but also our CTD profiler show an increase of temperature of even around 0.5 degrees in some places of the submarine volcano over there, and also anomalies in the silicate, in the nitrate, anomalies in the perturbation of the Brun bisalar frequency, the anomaly of the density, turbidity. So something is going on up there. Okay, so something interesting, so we need to return and to see what's going on. And finally, and this is my last slide, so I'm in time, don't worry about that, is Henry Submarine Volcano that is a little bit far away in the southeast part of El Hierro Island, here, and normally it's a submarine, it's a seamount that should be it's really old, it's more than 150 million years, something like that. But in one cruise, in previous cruise, together with our colleague from Germany, University of Bremen, sorry, I forgot that. We found several physical chemical anomaly in some part of the seamount, but they couldn't take any water samples because they were not ready for that. They only have a pH sensor, an RP sensor. That was the only thing that they had. So I was on board, and we decided to return to the point with one of our crews in order to with a big vessel to obtain water samples and to see what's going on there. So we arrived 3 or 4 months later to the same point, and we again registered several diminution of the pH, anomaly for the RP, increase of the turbidity, and also a perturbation of the nutrient in the area. So also there is something that happened over there. And that's all. Thank you so much. If you've got any question, welcome. Thank you.
Yep, so we have about 2 minutes for any quick questions.
I was just wondering if you could tell me anything about if you use any unmanned vehicles, so drone flights, with your research, and if that's a plan in the future to start using more drones, if it was possible to attach your rosette onto a drone. I know I'm asking a question of creating your own drone here, but I think that'd be very interesting, and if there's a plan in the future to incorporate drones into your research.
Yeah, sure. Actually, it's going to be a talk, especially speaking about the drone, because that was a tool that we were using in La Palma Island, and was a fantastic tool. Now to see the processes of the lava flow and everything. So yes, we are using a huge drone, not only with several thermal camera or whatever, but also to take water samples. No, really close to the lava. No, you know that it's really dangerous for a ship to get closer to the lava because so in order to avoid that and to increase the security of the person that are working over there, what we are doing is using drone that go there and take the water sample for us. So yes, for sure, we're going to use.
Yeah, okay. Eugenio, thank you for your talk. My question is similar to Henry and Medi Volcano. Have you recognized another volcanic structures that you think might be monitoring?
Actually, there is a hundred of them. I don't say a million of them, but yes, for this reason, we work together with our geological team. Here is present Juan Tomás Vázquez Garrido from the IO of Malaga, and he will do a talk later. The more important thing is that the marine geologists have the eyes. No, in this structure, we only measurement the whole water column. So this combination, this multidisciplinary team and synergies are the more important in order to to start doing science in the sea. No, so for sure we are working together, and every time that is a candidate for be observed, we will be there.
Okay, thank you. We'll move on to our next talk, but we'll have plenty of room for questions after the talks as well. Okay, thank you, Eugenio. If we can just thank you, Eugenio, again.
Okay, so good morning, everybody. Thanks very much to the organizers, Eugenio et al., for this new invitation to participate in such an interesting symposium, full of nice and outstanding people, many colleagues and friends. Okay, I'm taking off the camera so to have a better connection from home. Okay, and so I'm very sorry for not being there, but too many teaching duties this period. But okay, it's good enough to share with you our recent results in Tagoro with our interdisciplinary group, EAO, USAL, and other institutions. This presentation is not being really specific or super technical for petrologists, geochemists. This is in order to avoid that people start to run off from the room there. And so no panic about that, but it's mainly for a general audience of a master course studying different disciplines within the earth science, and is mainly consisting of show that the results of in Tagoro, and we try to connect the magmatic processes at depth with all the geomorphologic features at surface on the seafloor, with the super team of the EAO and their super tools available to do this frontier science in submarine volcanoes. Okay, so okay, so as mentioned, for this wide and general young audience, the presentation is showing more or less how is our working methodology in our group of volcanology, petrology, and geochemistry, and it's showing how to learn, or how learning to read the information written in the rocks, which is fundamental, essential to improve the knowledge of the magmatic volcanic processes occurring at depth, where, you know, scientists have no direct access, of course, especially at the moment of these processes are ongoing. No? Okay, so even more important, okay, because at the end this is basic science, no? But the application is it represents
Antonio, sorry, can you hear me?
fundamental information to
Antonio?
advancing prediction.
Hello, Antonio.
Which is the base of the monitoring task. We need to understand the behavior and conditions of the previous eruptions to try to better understand the upcoming
Antonio,
one.
sorry, can you hear me? Antonio?
Yes.
Yeah, I'm Eugenio. Could you put the slide mode in full screen, please?
Okay, sorry about that. Wait a second.
No worry. Thank you so much.
Now it's better?
Yeah, Antonio, thank you so much. Sorry for that.
It's fine now?
It is fine. It is fine. Thank you.
Okay. Okay, so as it shows in here, no? Let's learn to read the sentences written in the box. This is our key target. So, as mentioned, the only direct access to the material beneath the volcano, in this case, in this submarine scenario, is through the products emitted by the volcano itself. Huh? And we need a special team and tools to get access to this material. Okay, these are the material taken with the Ángeles Alvariño in the frame of the Vulcana and volcano projects from the IEO. These are the rocks that took off from the dredges. Here is Eugenio in the rock with the submarine, the Rosetta, and okay, in this working procedure, we start reading those sentences written by the Earth processes at depth, and we start normally, or we should start. All petrologists know about this. That we have to spend hours and hours under the petrographic microscope to understand the main textures and relationships between the minerals included in the rocks. Okay, and we paying special attention. You can see here these beautiful olivines, pyroxenes, if they are including melt and fluid inclusions, these beautiful plate-clay microliths, which is the degree of alteration, the amount of bubbles, etc. And this is the first and fundamental step, and then we continue with, as I tell to my students, we are trying to convert our rocks in numbers. First, geochemical numbers, in that sense, through a wide variety of advanced analytical techniques. Right? So you can see all the diagrams showing major, minor trace compositions on the phenocrysts, on the bulk, on the lavas, etc., etc. So this is essential for keep reading the sentences reading at depth. Okay, so combining petrography and geochemistry, this is other techniques we apply, stable isotopes, trying to track the fluid's provenance, if they are primary from the magma, if they had some interactions with meteoric waters, calculations of residence time at depth of the magmas, then all the thermodynamics behind of the by using the composition to understand pressure, temperature conditions of those equilibriums of the magmas at depth, etc. Okay. Oh well, and this is, as mentioned, essential to understand the magmatic volcanic story of the volcano before and during the eruption. Okay. Sometimes we are able to combine other geophysical techniques. Of course, when you are working with the EAO and a submarine scenario, you need as key material all the geomorphological bathymetric information by these experts on the vessel. And that year we also were able to study some magnetometry information in those days during the oceanographic cruise. Okay. So with all this, reading those sentences, reading in the rocks, and with combining with the other disciplines, or the geophysics and so on, we have just seen, we are able to integrate a whole picture of the magma plumbing beneath the volcano. So we are able to understand, or better understand as much as possible, how the process before and during the eruption was occurring there. Okay. And this was pretty special, connecting, let's say, for first time, these observational features at surface with the provenance of the magmas from depth. Okay. Okay. The tears come up when all the pieces of the puzzle combine and match perfectly, like in this case. So my students know how much I cry when I teaching all this. The important also thing is that all disciplines get improve each other when they are combined, and this is at the end one also of the objectives in modern science, and young people must know this. Okay, we should, or we must, combining all available disciplines to better understand any geological process. Okay. Okay. So in summary, we are able to summarize several of these results, trying to constrain the provenance of the magma chambers at depth, if they suffer any mixing process, which was triggered by the other, and was similar evolution of the magmas if we compare the 2011 and 12 eruption with previous ones. There is a current magnetometry anomaly under Tagoro at the moment, and we were able also to estimate a minimum volume of the products emitted by the volcano. Okay. Okay. So this is summarized in this kind of scheme.
This is summarize. This is summarize.
Sorry? Okay. This is a summary of our working group methodology. So we combine all the petrological and geochemical techniques with spectroscopy tools as well, noble gases, experiments on the other side with numerical modelings, both thermodynamic and numerical, which combined with all the geophysics, geodynamics, and geochronological, we are able, more or less, we managed to always advance in the knowledge of the geological problem we are studying too. Okay. Okay, so keep reading. This is the message of the talk for the young scientist. And there's a special paragraph to read under Tagoro, which is a special one because it combines for first time noble gases with olivines and corals. Corals, as any other submarine organisms, as witness of the eruption. So we know that the pre-eruption signals under Tagoro in particular, or in any other volcano in general, geophysics, seismic activity, or geochemistry from the gases emission. And both signals are normally registered by the monitoring groups when the eruption is already ongoing. Okay, but however, sometimes society is not time enough to react. Okay, we can remember the tragical episode in Monton Take in 2014. So we realized during one of the oceanographic cruises that a special feature we realized there was some corals happily living and witness of the eruption of the 2000. We were observators of the process, and we thought these special guys that were living in here, and we thought that probably in a closest system, or closer than the atmospheric system, which is the submarine one, combining the gases trapped in the magma chamber at depth with the signal trapped at surface, we were able to kind of tracking the degassing magma chamber at depth when the eruption trigger start. Okay, so everyone knew that the beginning of the eruption started in October 2011, but the seismic activity started in June. We studied the corals a couple of years later, and constraining the growth rate of these organisms, we realized that the black corals trapped the helium-3, helium-4 signal coming from the mantle 1 month earlier than the seismic activity. Okay, so this means that the geochemical signal was even faster than the geophysical one. Okay, this was a pretty strong result from the volcanic community, and this means that this novel forecasting indication may help to constrain the arrival time of a magma chamber getting nervous at depth before the eruption is already inevitable. Hopefully, among all of us, we will go little by little advancing in this point. Okay, and I think it's just in time. So thanks very much to everybody, especially to the EAO group. Yes, and all those able to reading and loving rocks. Thanks.
Okay, thank you, Antonio. We have time for one quick question, if anybody has one.
If you have any question.
I can ask a quick one before we go on. Thank you, Antonio. That was really, really interesting. And oh, no, we do have one now. It's okay. I'll hold mine for later.
Hola, buenos días. Muchísimas gracias. Disculpen, hay una cosa que antes nombró Eugenio y ahora respecto a, por ejemplo, los valores magnométricos anormales en medida, junto a Eugenio, que comentó el comportamiento anormal sobre los valores físico-químicos. ¿Qué pasa? Que justamente se ven en este volcán una diferenciación frente a otros lugares del mundo en ese tipo de medición de valores. Gracias.
A ver si te entendí bien. ¿Quieres decir que los valores anómalos que hemos registrado en algunos volcanes submarinos, que si son totalmente distintos a otros volcanes del planeta o...?
Porque lo nombraban como un valor anormal frente a los...
No, vale, te explico. Un valor anormal frente a la monitorización que nosotros llevábamos haciendo del mismo volcán en los últimos 10 años. Y ahora... The question was if this physical chemical anomaly that we were registering in the submarine, in Tagoro submarine volcano, these were different to other submarine volcanoes around the world, and no. And the question was that the answer is that the value that we were registered in the submarine volcano Tagoro in 2020 was different, completely different from the one that we were registering for the 10 years of monitoring the same submarine volcano. So for this reason, we were a little bit, what's going on here? If the submarine volcano were during 10 years in the same behavior, why you have already changed this behavior? So this is that one. Okay.
With her talk, IARC IMET activities during the 2021 La Palma volcano eruption. Thank you.
Hi. Yeah, okay. Hello, everybody. First, I would like to thank to all the Vulcana staff for the invitation. It's really a pleasure to be here to give an overview about the activities developed by the Spanish Meteorological Agency during the La Palma volcano eruption in 2021. Well, here the presentation will address just 4 key points. First, we will focus on the IMET contribution and the role played by the Isanya Atmospheric Research Center, or Isanya Observatory, where I work, giving some results and key results about all the experiments and measurements we took in La Palma together with the Isanya Observatory. In addition, I will take the opportunity to present the COCON Spain. It's a project, it's a national project. It is starting now, but it was present in La Palma during the volcano eruption. So we will see later the relationship between our COCON activities there and the national network we want to set up in the framework of a COCON Spain project. Finally, I will sum up with some reflections. Well, first start. The participation of IMET in this kind of volcanic stuff, let's say, starts mainly in 2084 with the establishment of the PVolcan by the government of Canary Islands, where several institutions, IMET between them, participate in the advisory and scientific committee. This committee has the main responsibility or the main mission to provide support and advice to the decision making to the management committee. So finally, as all of you know, the final result was a daily report from this scientific and advisor committee, just collecting all the information, evaluating all the information available, and provide some evaluation about the current status about the volcanic process. Well, in particular, IMET as a national authority and national meteorological authority has the main mission of advising in meteorological matter, of course. And to do so, we collect all the information, all the observation available for us, like a satellite platform, ground-based meteorological station, atmospheric station, vertical profiler station. This information is combined with the weather forecast, specific reports, and chemical transport model forecast, just to have an idea and evaluation and all the information to try to assess and evaluate the weather and atmospheric condition during this crisis. Special attention, as you can imagine, was paid on air quality conditions and transport, because they have an important implication on health and other stuff. Well, to support all these tasks, deployed a very huge instrumental deployment in La Palma, just covering all this stuff. We reinforced all the meteorological and weather station there, but somebody? Ah, okay, it's me. Okay, okay. Well, I'm sorry. Well, one of the most important thing, and I think that it was the first time in a volcanic eruption, was the setup of a new aerosol profiling network. It was ad hoc for La Palma. It was a professor installation there, just to try to monitor the height, the volcanic plume, and also to track the transport of the volcanic plume. Both aspects are crucial to understand the evolution of the volcanic plume when it is in the atmosphere. Also, we support the Canary government air quality network, just installing new instrumentation on site. And also, of course, we install instrumentation dedicated for aerosol and gas research. All this on-site instrumentation was complete by the comprehensive, complete measurement programs we have at the Isaña Observatory. Isaña is a global atmospheric watch observatory belonging to the World Meteorological Organization. So there we have a very complete measurement program to monitor solar radiation, atmospheric composition, gases, etc. Well, here is the list of the all instrumentation we deployed in situ in La Palma, just to have an idea about the instrumentation we have to install, move, and run in real time. It was a really huge effort for us, but of course, of course, it was the result of a collaboration of multiple institutions, national and international groups supporting us. Well, moving on the key results, I would like to show, give some ideas about 3 examples. The first one is our approach to track, to monitor the transport and height of the atmosphere of the volcanic plume, just setting up an aerosol profiling network around the volcano. The second point is the impact on air quality condition. And finally, I will show some example of the synergic approach to evaluate volcanic gases at different places, La Palma, Isaña, and using different measurement techniques. It's just how all the information we can get, all the conclusion we can get when we have different measurement techniques. Well, first, as you know, mainly in the first phase of the volcano eruption, there was several events of long-range transport reaching America, Africa, Europe, as you can see here in the simulation of the CAMS model by Copernicus. Well, the transport, it was in the volcanic plume was mainly confined between 2 and 6 kilometers of altitude. Aerosol and gas injection were confined in this layer, in this lower troposphere layer, because as you know, the volcanic explosive index of this volcano was really low. It was only 3. So to try to track and monitor the transport and the height of this volcanic plume, we set up, as said before, a new aerosol profiling network. It was made up of 5 new stations. Ruego a los muchachos, Tazacorte, El Paso, el aeropuerto y Fuencaliente. As you can see here, all the stations are located around the main points, the volcano, just to try to track any direction of the volcanic plume. So in this station, we install instrumentation like this. It is a vertical aerosol profiler. So it provides us information about vertical distribution of aerosol and clouds. Here you have de punta. Here you have an example. This is the back scattering signal, and we can see that the top of the volcanic plume is located between 4 and 5 kilometers. And also here you can see some rain events. We call that rain events. Just the ash is going to be deposited on ground during the day. So all this information can be extracted from this vertical profile. So we can know in real time the altitude, but also the vertical distribution and all the transport inside the plume. Well, with this instrumentation, we got this figure. I think that is one of the most important figures for us. It was in collaboration with the IG. And here you see the time series during the whole eruptive process of the top height, the column eruptive column, the ash cloud height by IGNE, and the height of the ash cloud height by IMET. As you can see here, the agreement is excellent, is amazing. Just taking account, we use very different approach. So this result, this figure, provide us a very confident result about our different approach. So it's really a very important result, and it's the first time so far we know that both approaches are combined to provide this data. Here, the second important thing that is we clearly identify two different phases in the process, in the volcanic process. The phase one was characteristic, it was a more explosive, more effusive activity. So the normal or the usual injection height is located between 3 and 5 kilometers, and the second phase, the top, the maximum height was lower, and it was confined between 2 and 4 kilometers. Okay, the important thing is combine this information. It has value by itself, but it's important to combine this information with the time series of SO2 mass emission. This estimation from the NASA monitoring home, it was estimated by satellite data. And as you can see here, we clearly is more clear that in the altitude time series, we clearly distinguish the both phase, the first phase with both explosive and effusive activities. So we have important gas and aerosol emissions during this phase, and the second phase is more characterized by effusive activities. So there is less energy in the system, so we expect less gas and aerosol emissions. So the last point here, and it is very important, is for example this curve and this estimation of SO2 is evaluated using a fixed height for the eruptive column, and NASA assume a typical height of 8 kilometers. So when they use the dark brown curve, use the real altitude we provide, we measure there, and as you can see, the evaluation of the SO2 increase significantly. So when you, the final conclusion is when you use some standard approach, like another volcano, you can underestimate so much the amount released. And this magnitude, this parameter is one of the most crucial in the evaluation of the eruptive process. Well, moving on impact on air quality condition. Well, you know, Canary government reinforce all the instrumentation there to try to monitor as best as possible the air quality condition there. So they set up 6 new stations close to the volcano, of course. But also, private company puts a lot of effort to try to improve the government, the Canaries government air quality network. So providing a lot of instrumentation. Palace is an example, but there are other private company providing instrumentation for this event. Well, some result about that is here is the time series of SO2 in hourly and daily means. As you can see, we get what we expect. The stations are those stations close to the volcano, La Palma, El Paso, Los Llanos, Tazacorte, and also we include Design Observatory as reference. So we found more or less what we expect, the higher number of days with when exceed the World Health Organization air quality limits are related with the Los Llanos station. It's the closest city to the volcano. But also we find some interesting result is that at ISO we record the highest, the maximum daily and hourly SO2 concentration. It was at the beginning of the eruption, and we got more than 7,700 micrograms per cubic meter, but our instrumentation was collapsed. I mean, we can measure more than that. So I think that the concentration were higher even. So this is due to because, as said before, the volcanic plume was mostly injected about 3 kilometers, 3-4 kilometers, and the transport was directly to the Sanya. So the volcanic plume reached in a very pure condition, without mix, without any mix, yes, let's say. So we are taking measurements in really, really free condition and poor condition. Oh, vale, sorry. Well, it's okay, I can go. Well, the second point is with this data, we try to understand the modulation factor behind. We have to think about, of course, the volcano process are responsible. I mean, the SO2 emission, the altitude of the plume, this kind of thing. But the one important modulation factor are the meteorological conditions. So we have to keep in account that Canarias has a very stratified atmosphere. So the volcano plume was trapped in our boundary layer many times. So this was the main cause for the high concentration at the surface level. So, well, I designed all the measurements in La Palma were completed by our research program in Tenerife, in Izaña. So, con this information, combining all the information, we can have some very nice results and try to understand the evolution of the volcanic process, just analyzing the volcano gas ratio. So these figures summarize the volcano gas ratio between different volcanic emission components together with the seismic signal as a proxy of the volcanic evolution. As you see, the agreement between both data sets are really nice. So we can use the volcanic and the variability of the volcanic gas ratio as a proxy. It's also a nice result, a nice consequence of this analysis is we can estimate the total amount released of different compounds. If we consider, or we we know the total SO2 amount, for example, from satellite data. Using this gas ratio, we can estimate CO2 emissions, the total CO2 emission or other components. Well, the last part is just related with the greenhouse gases. CO2, of course, is important in volcanic process, but CO2 is important for other stuff. It's the main, as you know, it's the main driver of the global atmospheric global warming. So volcanic emissions are less than 1% of the total emission from human activities. So this is the idea behind COCON Spain. We try to set up a national network for monitoring the atmospheric composition of greenhouse gases, like in La Palma. This is the timeline. The greenhouse monitoring is now a strategic priority for the European Commission, priority for all the organizations dedicated to atmospheric composition, and we will play with them. So we are going to, this is just some idea about the current distribution of measurements of station measurements greenhouse gases in Spain. As you can see, there is nothing. We call that the empty Spain. It's just a few stations. Design Observatory is one of them. So we try to improve the national observing system by setting up this national network for atmospheric composition, for greenhouse atmospheric composition, but based on the COCON strategy. Well, just some ideas to sum up. It is a national network, is supported by the European Next Generation Funds. We are talking about 4.2 million euros in the 2023 to 2025. This project is implemented in the National Plan de Recuperación, Transformación y Resiliencia, and we will plan to install 12 stations in the first phase, and the project will be the national node of the international research COCON infrastructure, which is managed by the Karlsruhe Institute of Technology, supported by the European Space Agency. Well, we are using this instrumentation. We use this in La Palma too, and Isaña, as you can see here, will be the reference. Well, the main idea is to build up a permanent consolidated greenhouse observation system at national scale, even possible for volcanoes. I hope not, but okay, it was just this collaboration effort of different national organizations, and that's all. Just to sum up, two ideas. The volcano eruption was an opportunity for science. It was an excellent, amazing natural laboratory, is evident. And the second, it was also a tragedy, but for science it was an amazing opportunity. And the second idea here is this: the empty Spain is not only related with atmospheric science, in general. It's also an opportunity to improve our observation system, improve our knowledge, improve our collaboration. So that's all.
So today I thank the organizers for the opportunity to present. To present a book that we have been working over the first few years, and it's already like 3 talks, and obviously we haven't talked about my book, and some of the Spanish people, those that are not that young, will remember this very funny moment in the Spanish TV where a very nice, well-known novel writer complained about not talking about the book. So it's not really my work, it's not my book, it's the work of a community. So when we started working on this project in late 2019, we come together several institutions to realize that there was a big opportunity to zoom up in advance of the 10th anniversary of El Hierro eruption, the first and most well-monitored eruption until that moment. Hi, Jaime. To sum up this knowledge that we have been gathered. And the big surprise is that we start collecting some contributions who wanted to write things, and we achieve gender equality in the chapter leaders of this book. So we were moving forward. We were very pleased to achieve. But what is the context of this book? So this book comes from a very long and windy road over the past 30 years. Well, we are heading towards 30 years of what we can consider modern volcanology in the Canary Islands. The first hiccup, and that was I was very, very young PhD student at that time. Some other people can talk more properly about what happened in Tenerife in 2004, 2006. That was a catalyzing moment to realize that actually it's not only in the textbooks that we are a volcanic territory, it's actually things move behind us, beneath our feet. So the government had some capabilities, realized that something should be done, so published some passed some law that make the volcano monitoring to be official, and things start to move. Just on time to be ready to have the first monitored eruption in our history, El Hierro in 2011, 2012. So this is not about specifically about the science, but it's to realize that we publish a lot, and there was no like a proper sense of what we have gained after that. Things that also happened that improved the situation is that Volca was published in 2018. And in 2019, 2020, we realized we should do this exercise. But COVID-19 happened, and then mysteriously a fracture opened in La Palma, and the project, instead of commemorating the 10th anniversary, commemorated the 12th anniversary almost. In August 2023, we finished the book, it's published, and everybody is invited to download a PDF copy and have a look at what we have gained, but also what we try to emphasize in this book, or that was the philosophy, we achieve it in large part, is to show what we have not achieved yet. And that's very important because younger people will coming behind us and keep working on this, and things will not finish with us by no means. You know, volcanoes are very, very complex systems. It's a fluid, it's a solid, it's a gas phase, it's three-phase, it breaks, it heals, it keeps doing funny things. So this is not, it's just saying that science volcano is going to last many, many decades, and it's a very fruitful field of research. So I'm going to go through each chapter, just only giving glimpses, probably just highlighting the challenges rather than what we have learned, because I cannot take the floor on behalf of every author in the book. So we divided the book in four main parts, starting with the overall context of the volcanology in the Canary Islands, what we know and what we don't know, and then move on with the deep analysis. You know, the vast majority of the book is about the eruption, and then some other implications for the society. So, what? Oh. My role was secondary, was just only a director of orchestra, you know, like that the people chasing that they don't delay too much, and I didn't want to even contribute in any of the chapters, except that we couldn't find people that was interested to write something at the lithospheric level, wide context. So I step up and I say, well, this is what we think we know, but actually Canary Islands is very diverse. We completely lack a good imaging of what happened from the bottom of the lithosphere all the way to the surface. And without that knowledge, I think everything will be just patchwork. So until we make a big step to understand why the Canary Islands in only 1 million years is able to generate a very large, diverse lithologies, where Hawaii is just constrained in a small corner of the compositions, we will probably be missing an opportunity to put Canary Islands in the forefront of what it means to understand intraplate volcanoes. So that summarizes as increasing the geological, geochemical, and geophysical studies to better understand the static part, but also the dynamic changes in the composition and physical-chemical conditions from the base of the lithosphere all the way to the surface. And this is something that will require a community effort. So then we move to try to understand what has not been understood until the eruption in 2011. So geological knowledge remain very difficult because we are talking about processes happening in the deep time. You know, deep time is being used in planetary sciences to talk about the beginning of the planet. But in geology, in our context, it's just simply, if we will be able to go back to 160,000 years, that will make a huge difference. Why? Because, for example, El Hierro only have 14 absolute ages, according to the revision by Stavros and co-authors. But a recent a recent publication just in the southern reef of the island identified 90 monogenetic structures, which means that we are super underestimating our understanding of the timing of eruptions way before the historical records. So this is a critical information to create scenarios for the hazards that we can confront, not only the worst case scenario, but the most probable ones. So then, obviously, everybody understands now that volcanic eruptions in the Canary Islands happen also in the submarine environment, but that was not the case before 2011. So our managers, even including myself, we were neglecting that part of the volcanism. So Guillén, Carmen Romero, and Inés Galindo went through the coast, mapping all the possible deposits, look at the shallow reefs that could be indicating of eruptions, and did a very nice compilation. Something that I think it's surprising, because you find this information very scattered in historical records, in chapters of books written in Spanish. This chapter highlights possible Surseyan eruption with less than 20,000 years. Obviously, dating will have been better, but this is based on fresh deposits. And then they went through the historical documents, and they found 3 eruptions that very likely had happened, and undismiss or corroborate that some of the evidences for others were doubtful or very unlikely. So this is a very important piece of information, because El Hierro Island, being the youngest, was not identified to have historical eruptions in the common textbooks before, at least to my knowledge, to this chapter. But this is written. Surseyan activity is an important type of activity, should be included in the new revision of the PEVOLCA, as well as the scenarios and protective measures this. Another thing that highlight the authors is that the increase of sea level rise would prove an important aspect to study to understand the assessment of the likelihood of these hazards, and so on. So the next 10 chapters were focused on the eruption in itself. The first we divided with those related to what is more familiar to me, the geology, geophysics, and monitoring. And then the next ones will be the monitoring environment. I think Antonio already talked. I missed it, so okay, I skipped this. It's essentially his talk. What we can say is that his message should be that we should take more on board modern microanalysis of modern petrology. So there is a lot of increasing capabilities in microsounds and profiles of crystals, etc., that has not only been scratched the surface in the volcanology in the Canary Islands. So is definitively the message to look at these wiggles and try to interpret properly to ingest this information in the monitoring. So then Itaiza put together a very nice team that start to look at not only the crisis around the eruption, but the subsequent 6 swarms that follow the eruption. So what I read from the chapter is essentially that volcanic unrest and crisis are much longer than the eruptions in itself. And this swarm plus the alert level on which we are in La Palma demonstrate that these crises are protected. They don't happen over short times. We should be prepared to be resilient for working on something challenging over years. And El Hierro plus La Palma is showing us that the monitoring of these processes has to be increased and maintained over time, the effort. The chapter highlights that combining geodesy and seismology can reduce significantly uncertainties, sometimes by highlighting some things that do not coincide, which is deserved to make progress, and the capability to know exactly where the magma reservoirs are located, much more precisely than petrology or field observations. This is a very powerful tool that later on demonstrated in La Palma that was very important. So the target or the challenge is that we need to move towards more quantitative interpretation rather than correlation of variables that will make more stronger predictions. And that the fact that the intrusion that led to the eruption was very similar in precursors to the subsequent swarms. So distinguishing what makes a special that swarm with respect to another will be a very valuable tool. So the importance of shallower reservoirs at the oceanic sediment layer, I think it keeps demonstrating that it's important and should be recognized for the interpretation of La Palma, and so on and so on. So essentially, the challenge is that we are over a very small territory. Our volcano monitoring networks only span mostly the island. So this is very small with respect to the depth that we want to investigate. So something has to be done. I don't throw the dart, you know, the submarine monitoring should be more important. Seafloor monitoring should be important, not only for the environment, but also for the geophysical part. Carmen Lopez led a large team on an incredibly complicated task that is looking at the long-term, short-term precursors associated to volcanic activity, not only leading to a Hierro eruption, but in general. You know, she went through going back to very difficult data sets that varies in quality over time, back from 2000 all the way to 2011, and start to look after, okay, what has changed? Why did it change? Does it mean that we can use that as an indicator? Her message is that all parameters are important and not a single one can be considered enough for making alerts. In her view, so the precursor has to be interpreted as a subsequent sequence of evidence. And the message is that without the strengthening in the monitoring, as I said, the IGN start to improve the seismic network in the islands, but unfortunately it was not as it is now. And without that data, even if it was scarce, it was able to detect seismicity 3 months before the eruption. If we will only rely on the accounts of people, the population only felt earthquakes 2 weeks prior, which goes back to interpret the historical records about how long precursors happen before eruptions. We are biased because precursors happen over a long period of times, you know, short times, long times, in different forms. So monitoring is very important and should be strengthening. So Tomás Juan Tomás will be talking later, so I'm not going to spoil anything, but those images are just so beautiful. I just cannot tell you, you know, go download explore, it's mesmerizing how much detail you can gain from the effort of the oceanographic surveys. What I can summarize is essentially that high-res bathymetry should be necessary over a regular program. They highlight some time scales for some of the processes, maybe yearly, every 2 years, every 3 years, depending on the level. And they also go towards the same conclusion as Carmen Lopez and other authors. You say, we need more submarine monitoring infrastructure, cables, and submarine environmental and geophysical stations. So the next 4 chapters, I totally don't know about that. I honestly, I can tell you they are really amazing. I hope the next of the session can go deeper in these topics. What I can highlight is, Eugenio, come on, 31 oceanographic cruises. I think this is a world record, and I think you have even surpassed by now, right? So keep going. This requires a lot of effort, a lot of commitment. Keep working. I have all my support for you guys to continue. It's very important for resolving many unknowns. Alba, here, you can probably talk better than this, but I can tell that it was very interesting to see that this the nitrogen species were not as expected. Ammonia seems to be very important. And the type of dispersion, either during the plume or dilution processes, keep being not studied properly. I suppose I summarized properly that the fluxes are not known because you know the concentration, but not the fluxes. So fluxes need to be solved. And continue this as a large database should be important to continue. Isabel did a fantastic job. I even understood this chapter. So she was very clear writing. It's a very short chapter, but it's very, very clear that the changes, the way they did it, the type of summary of the results was extremely clear. So I invite you to go and read. So she found differences in microbial activity in the plume and the post-eruptive phases. That's summarized as the cyanobacteria declined at the depth of the eruptive vents. I don't know even to pronounce these things. Heterotrophic prokaryotes are more abundant during the eruption, which is surprising. More activity, biological activity during the eruption. And some other facts. What she mentioned is that we should make much more clear why the changes happen in post-eruption. So active vents seems to still have anomalies nowadays, and they should work towards a new methodology to identify well the volumes of water that are affected by the volcano with those that seems to happen, there's just simply the natural variability. Yeah. So one more work by Ana Sotomayor Garcia. So again, things that I don't really understand. But then let me summarize with 2 minutes, 2 slides about cascading risk. It's a hot topic. Many hazards have to happen, as in the tsunami and big earthquake in Japan that highlighted the cascade effects. Rock faults have been like a hidden dark hazard in the Canary Islands because they are underreported. They happen very fast. They happen in remote areas, and the crews in the municipalities tend to clean the roads, etc. So efforts like citizen science approaches to document this dark hazard tend to make the means to improve the situation. So rock faults are triggered by multiple effects, rainfall, seismic activity, etc. So it's very important. It even triggered the closure of one of the main roads in the island during the eruption in 2011. And it was not included as such in the PEVOLCA hazard law manuscript. So they need to be included, continue these efforts, move towards a better understanding of this process to produce alert system and better sonification. So the final point is that society is not passive to this event, so they can take ownership of it. And if they feel that this is part of them, they will make more value and protect it. So Vegas and co-author create not only something that is very subjective, like assign value to places or events or rocks. So they create a methodology that later has been used in real time to evaluate what parts of the crisis and eruptive site in La Palma was important to protect. So it's really applicable. That has led to some proudness in the community. So Restingolita, which was a volcanic product that happened to appear at the beginning of the eruption in El Hierro, is now displayed in some shops in the airport. So the people take ownership of it. So this type of work is more cross-section with social sciences and highlight the positive and attractive value of geosites. And that type of activity was essential to transform El Hierro as a geopark, a UNESCO sealed labeled category for a special site that has natural and also societal value. So as I said, please download the book, and I can just say that this will have not been possible without almost 124 authors, 24 reviewers, 2 science editors for this book from the YAPSE, and all the amazing support of the Springer editorial managers. So together, and this is the main message, we can do much better for the Canary Islands. And those are very few examples I was able to put together yesterday, you know, when we coincided with the crew in the IGN close to the volcano, international collaborators from Germany, surveys to understand the gases, the amazing opportunity that Eugenio opened us to go to the sea bottom, inviting generously all the institutions around. And I can just simply not advertise our outreach activity of the Ceniza and Lava exposition that is free to everybody to go on the Museum of Science and Cosmos. Thank you very much.
Okay, have we got any questions from the floor? Lovely. If you could just let me know your name, where you're from, and who your question is directed to so we know who you are. That'd be lovely. Thank you.
Hello, I'm Katie Chamberlain from the University of Liverpool. This is a question for Pablo. I was just wondering if there were estimates of the magmatic flux in the Canary Islands and whether there are any efforts to assess that, because that could be a way for creating that very large diversity in compositions that we see here compared to high magmatic flux ocean islands like Hawaii.
Hi, Katie. Nice to meet you. You gave the target a dart in the center. So I just yesterday received a book that we were looking after for a long time for the volcano compilation that the Hawaii Volcano Observatory has made in the past few years. And they highlight the legacy of Don Swanson. Don Swanson has made most of the work that is referenced in the Hawaiian volcano archipelago. And in particular, one that was of the first things that he did to understand when he arrived to Hawaii was to understand the amount of magma that has erupted over time. And no, there is no works in the Canary Islands that have done. We have already identified this as one of the main targets for us. But we know that it's very challenging. We are much older. It has been more erosion happening, and it's less mobile, the hotspot, as Hawaii. So we have a bit of difficulties, but it's true that just simply give some back of the envelope, NACIP science estimates of how much production has happened in the mantle beneath the Canary Island over the
past 30 million years will be very useful to understand some of these processes. I think for the evolution of, or adding to your comment, the evolution of many of the chemistry is also dictated with the not only the flux rate, the magma flux rate, but also the resilience time in the reservoirs. So do we have a hot enough crust to hold material for a long time? Did it freeze? How it evolves? How it mobilizes with the next eruptions? So these interactions, and this is what I was trying to say in the chapter I wrote, we need way more better imaging from the base of the lithosphere or the surface. And that includes the crust, but also the mantle. And we are very blind. We have blind spots in the Canary Island volcanism. Thank you very much. Very, very nice question.
Thank you, Katie. I think we have a question down at the front here.
Lovely. If you just, again, just let me know your name, where you're from, and who your question's for. Thanks.
And just a quick reminder, if anybody online as well has any questions, please put them into the chat and we can address those as well. Okay, thank you.
Hi, my name is Belle. I'm from Canada, and I'm not sure if the question should be addressed to you or to Dr. Fraile Nuez, but I'm just wondering what's the highest resolution of bathymetry that you have access to for monitoring the seafloor?
Your guess is right. So this is so from the tables I've seen 5 meters, but I don't know if the highest resolution of the surveys is 5 meters, or do we have 1 meter bathymetry?
Sorry, I didn't we're hearing to you because I was doing another thing. So sorry for that. I didn't listen to your question. It's my. Could you repeat the question?
What was the highest resolution of bathymetry?
Okay. Okay. So actually, there was a lot of kind of resolution in the area. But for example, Tagoro submarine volcano. It is Thomas is not here because I have another meeting. But the resolution is 1 meter and even 30 centimeters in some parts of the volcano. No, but normally is around 1 meter and 5 meter and 10 meter. But we are recording really high resolution bathymetry.
Okay, thank you. Another question down at the front. So we've got 2 actually down here.
Yep.
Thank you, Sharon.
Just let us know your name and where you're from. Thank you.
Hello, my name is Silvia. I'm from the University of Milano Bicocca. I have a question to Eugenio. This question came after the presentation, the talk also of Umaira. She was talking about the air quality during a volcanic eruption. If it rains and the rain reaches the oceans, do you consider also this factor? Can you distinguish maybe that the values, for example, of the acidification, the pH, etc., can come also from the rains and not directly from the lava who reaches the ocean?
That is a really nice question, and actually we could improve that because there was no rain at that moment in this area, so we could improve these beautiful things for the scientific point of view. But actually the ashes that were spelling the volcano was also driving and make a huge perturbation in the ocean, together with the hyaloclastita that was directly injected in the whole water column. So that was a really huge perturbation, and we need to study a little bit more about that because for sure there was a clear perturbation to the marine ecosystem in that sense.
Eugenio, I have a question for you, because you said in your talk, which I found really interesting, that when you were monitoring the Volcán del Medio, you found an anomaly, and not very long later you had a seismic swarm in La Palma. Now there are people of the older generation in the Canary Islands where the folklore is, where they believe that the volcanoes are somehow connected, and if you have activity in one, you know, that has an impact on another. The question is, do we pay enough attention to the experience of the people, of the residents, of the families who've lived here for generations? Because certainly 10 years ago, when I spoke to scientists here, they said, no, every system is independent. And now actually we're seeing that perhaps maybe the grandmothers of the Canary Islands had something to say on the matter. What's your view on that, please?
Well, actually, I have to say that the perturbation that we saw is not in the volcán del medio, was in the volcán Tagoro in 2020 that we saw some perturbation in the physical chemical perturbation that were really high compared with the monitoring that we were done in the previous 10 years. So for this reason, we did this report, urgent report to the volcano. Actually, we think that, yes, something was happening, something is connected. You know, the magma is going in one direction, maybe pass through first to under the Hierro Island, and finally reach or move something close to La Palma. This is how you can prove. I don't know. This we need this seismology and the geological and everybody working together. So for this reason is the interesting thing, no? That we can have one piece of the puzzle. But we need all the people together in order to see if this is a proper theory, in order to say if this is connected or something happening or what's going on. We need to do science together.
I think, sorry, I think it was just in the Guru first.
Yes.
Thanks.
Just your name first of all.
Hi, my name is Guro, and I'm a master student at the University of Oslo. And I have a question for Pablo. Yeah, because it was really fascinating to hear about this book project. But I guess in addition to this being very giving, it has perhaps also been a bit frustrating and stressing from time to time. Is this something you would, like editing a book like this, would you say yes to do it again for another volcanic system? Or have you gotten enough while doing this?
I would do it again, but probably I will call some more help. So single-handed this, it was a bit of a moment of excitement at the beginning and say, yeah, I can do it. But then it turns out that you have to handle some books and chapters that you are not really familiar with the topic, and definitively something that diverse will have benefited from other helps of editors. And yeah, definitively it's worth, and I think this review activity slow down and make a slow science, think on the challenges in the future is absolutely necessary. So we are in a very high pace of, oh, this eruption is happening, this place is a hot topic now. But looking in the long-term perspective, as Kathy was suggesting, very basic knowledge that is available in other volcanic areas is lacking here. And I think just simply not for lack of capability, it's just simply lack of slowing down. You say, okay, we need to build the strong foundation to then be able to put in the right context what we are not understanding that in isolation makes no sense. So yes, definitively, everybody do in your own field, but probably coming together with help, building a team, will be the message for trying to do something similar in the future, using one of these anniversaries or some landmark moment. Yeah, definitively. Yeah.
Pablo, thank you very much indeed. Anybody else on the floor? Yes. Aha, our lovely geo-intern scholar, local scholar, Sergio, so lovely to see you. Your name and your university, please, first.
Hi, Sergio Barra from the University of La Laguna. I just wanted to ask Omaira if there's any monitoring being done right now in Puerto Nao, in La Palma.
Well, it's a very nice question, but I can answer this question because IMET has not competition. Say we can't manage these diffuse emissions. So even we don't have instrumentation deployed there to take measurements, real measurement there. So really, I can. We are experts in indirect volcanic direct emission into the atmosphere, but this kind of diffuse emission are related with other processes that we can't manage. So I think that maybe the Canary government or maybe IGN, I'm not sure who is the responsible for this, but well, in La Palma is a huge problem, as you know. It's not solved at all.
Thank you very much, Maida. Anybody else?
Just down at the front here, Sharon, please. Thank you.
Oh, guys, you're making me run.
Oh, no, I'll do it in the next session.
No, it's fine. It's all good.
Hi, I'm Kat. I'm an undergraduate at Dartmouth College in the US. I actually have a question for Antonio. I'm not sure if... Okay. Then I was interested about what you were saying about the corals registering geochemical changes and kind of forecasting eruptions. And I was wondering if this system is either known to be able to be applied or if you think it could be applied to other organisms, either marine or subaerial, to help forecast eruptions.
Antonio, hopefully you can hear us.
Yeah, hola, can you hear me?
We can, thank you.
Okay, yes. We actually applied to get an instrument to be installed in the seafloor, just to try if this is a kind of new tool to really go further with it in terms of monitoring real time. But it's really a challenging stuff for any company. We talked even with a Japanese group that they promised me to build a demo one for 600,000 euros. You know, there's no program to fund this kind of stuff. So I went with an agreement with the Japanese colleagues. They are trying to build one, but it's not the exactly mass spec, of course, you have in the lab. So it's kind of a helium-3 leaking instrument to be installed in the ocean floor. And yeah, so yeah, we are still on there. But, you know, at least we know that this stuff is working well. So, okay, let's go. Hopefully in few years' time, we are able, from the technological perspective, to go for it.
And
yeah.
That's great. Thank you very much for that answer, Antonio. And thank you for bearing with us. We have time for a couple of questions more. Yes, Juan.
Hello, my name is Juan David. I am from Colombia. I work at the Servicio Geológico Colombiano. And my question is to Omaira. I'm curious about how do the stakeholders manage this crisis, because during the eruption there is a really big pressure with the information that you communicate, and I would like to know if you show this data that you compare with the IGN, with the HN, and I would like to know if during the eruption, do you have a methodology, an agreement or something to share this information together and communicate daily with the stakeholders, with the people?
Yes. I mean, the main to providing the height of the eruptive column, the ash cloud is responsible here in Spain for the IGN. So I met in this thing is just support their data, and we set up this kind of instrumentation because we are experts on this vertical profiling, and every day at 7 in the morning, at the midday, and even in the afternoon, we analyze all the information we have from the vertical profile, and we share every day with the IGN. So it was a really nice agreement, collaboration between us, just to support their reports. Yeah, sure.
Thank you. Anybody else? Lovely. Lawrence, we'll go to you first.
Lawrence Lane, University of Leicester. My question is for Eugenio. I saw on the presentation of Antonio the use of stable isotopes, and I was wondering in the IEO oceanographic cruises if this was implemented at all and what the applications of that on submarine volcanoes.
Sorry, say again. I can't hear you well.
On the IEO cruises, the application of stable isotopic data.
The isotopic data were done by you, right, Antonio? You can answer that question because you take that samples, right? Estás muteado, Antonio.
Okay. Can you hear me now?
We can.
Yeah.
Okay. So if I understood well, because the sound is not that good now, is if he means that if we analyze the stable isotopes on the cruise, you mean? Yeah. No.
Yes, on the ocean floor for the cruises.
No. We took the samples and analyzed in the lab. Yes. You can do it on the cruise, but only on the waters or gas samples. If you need to analyze on solid samples and extract the gas from the melt or fluid inclusions in the phenocryst, you need first to crush or melt the phenocryst in order to extract the gas and analyze under high vacuum conditions. So you have to do it on the lab by fluorination lasering. We do it in Salamanca University in our lab. Yeah.
Lovely. Thank you very much. I think we might have time for literally just one more question.
Hi, I'm Ashton. I'm from Dartmouth College. I have a question for Pablo. So you mentioned that you found several historical documents for recent submarine eruptions off El Hierro, and also evidence for a lot more activity in the ocean around the island. Is there similar work ongoing to figure out if the other islands share similar underwater characteristics, for example, south of La Palma?
Well, the work is not mine. I just only coordinate the book. Carmen Romero is an expert in historical activity in the Canary Islands, and I think my understanding is recently they opened to work in the submarine record since 2011 onwards, but they have found very interesting activity offshore Lanzarote, and I was in a conference a couple of weeks ago, and she were talking about very active activity in some of the platforms around the island. But being certain about what these shallow reefs, if they are historical, subhistorical, or so on, requires more work. I cannot answer for her, but I definitively is more aware now, the community, about the submarine activity and those that share characteristics to El Hierro eruption that was not producing Surseyan activity as such, but it was intermediate depth, and they labeled this intermediate depth as a way to classify or give an explanation to some very intense seismic activity events that happened in the past. So it's matching the account with possibilities. And in El Hierro, this I think is the most authoritative compilation so far for an island that did not have historical eruptions identified before the last 10 years.
Pablo, thank you very much. Just to let you know, the catering company who's doing our coffee break was running a little bit late because of the traffic. They are here, they are setting up, we will get our coffee, but we'll just have time for one or two more questions just while they set up. So Hannah, I think you had a question, thank you.
Hi, I'm Hannah. I go to the University of Manchester. I think my question is for you.
Okay.
I was just wondering, I can see the risks that submarine volcanoes pose on like marine ecosystems, but what kind of risks do submarine volcanoes pose on people living in the Canary Islands?
Yeah, I think we should be open for that. El Hierro, La Palma had very steep platforms, a very shallow platform, but they do not extend very, very deep into the marine environment, so the risk is a bit lower because the area on which a fissure can open is smaller. But other islands had a much more extended platform around the islands, and there you could have Surseyan activity. Surseyan is the mixture with seawater of the normal magma, and that can be highly explosive, as we have, or everybody remembers of the activity in Iceland when you melt a glacier, mix it with the magmatic material, it can suddenly expand catastrophically and produce very fine ash and very high columns of activity. So it will be, the hazard will be like bombs, ashfall, ballistics, etc. But it should be like a very confined hazard, making a relatively small evacuation around the coastline could be enough, yeah. But, we will be surprised by Earth, obviously.
Thank you, Pablo, thank you. Somebody else? Yes, Beth, thank you.
Hi, my name's Beth. I'm from the Open University in the UK. My question is to Pablo. And when you were talking about one of the eruptive products on El Hierro, you said that the community had really kind of taken hold of it and were displaying it in airports. You called it restingolita. Could you tell me a bit more about why it's special?
Well, I think everybody in the Canary Islands felt kind of very close to it because first it was given the local name. Restinga is the southest most point and town in El Hierro. So it's a popular name that people know. Oh, Restinga. And when the first products appear, popular science colleague in the community give the name Restingolita, light rock and Restinga. Then the more scientific term for this is Xenopamis. So it's pumice that has been expanded, a material that is coming from the mingling. So Antonio is here probably, or Ramon Casillas, they know more about petrology. But essentially we believe it's the mixture of sediment, mingling of sediments on the magma, basanitic magma, the basaltic magma, and that produced this very fine grain, high porous, very light material that is able to float and did not sink. That's why there were so many samples that the people took from the beach and they kept in the houses or in the bars, like this. Something that is curious about these Xenopamis or Restingolitas is that they appear in other historical eruptions. I wasn't aware, to be honest, and I was surprised that there were more in recent historical eruption. Talking to other experts like Valentin Troll, in Sweden, Uppsala, he told us that it's actually relatively common to see it in many eruptions. So, and they have evidence from different parts in La Palma. There was a master student that was working on them. And actually in La Palma eruption in 2021, we found them, Thomas. You found a big piece, and it's actually part of the exposition that you can see in the museum. And I think, yeah, this is a very, scientifically, it's very important. And I think the people took pride of, just because this science communicator make the right word in the right moment, and the people took it as their own.
Thank you, Pablo. Any more questions from the floor before we break? Yes, Peter.
My name is Peter, and I have one last question for Pablo. It was about the rockfall hazards and the citizen science approach that you were mentioning. I'm like wondering what the system looks like for that kind of citizen science, if there's like reporting involved, and what type of details you would need from the citizens conducting that.
Well, I talk again on behalf of the authors, Juan Carlos Santa Marta, Inés Galindo, Nieves Sanchez. They have been working over not only during the crisis in 2011, but onwards. And they create a tool, like an app that you can download in your phone. Take a picture, report it, say where it happens, and actually harvested the GPS location from your phone, and that enters in a database. This is a huge leap forward to what has not been able to document. You know, you can imagine geological surveys all across the world struggle to document things like small volume that happen, but they could produce damage in roads, in infrastructure, water canalizations, pipelines, etc. We usually tend to report very large volume collapses. You know, like 2 years ago, maybe 3 years ago, in La Gomera, we have a very large collapse in a cliff. Actually, the week before the eruption, we have also cliff collapses in La Palma. And yes, those are reported, but where is written that information? You know, usually it's in a newspaper and they don't enter in a database. So the first thing that science challenge is at least document what's happened and not get information get lost. And this is a very huge task that usually is not very rewarded in the scientific community.
It's a very good point, and actually it's one of the reasons why with GeoTenerife we didn't have any role in the immediate emergency, but obviously we had the resources to be on the ground throughout the event, and we just started recording lots of interviews, lots of testimonial, and we've made everything absolutely available through open source. And in fact, AJ, who is here with us, will speak to us a little bit later about what that is. Because there are so many stories otherwise that are lost, so many witness testimony that is really useful to take time, and it's very important to record those in the moment, I think, because sometimes after the event, memories change, perhaps they've seen something in the press, they've had conversations with friends, and you lose that immediacy. And we're making that available completely openly to the whole community. And obviously there's universities and researchers who are starting to use that, which is fantastic. We've still got a lot to put on there. It's a lot of work, as you know, but we're committed, so that's great. Any more questions from the floor? Yes. How's that tire? There's two young gentlemen here who are who work with Dr. Richard Brown at Durham University and had a bit of an incident with their rent-a-car, but it's glad to see that you're here today.
The car is fine. We got a new one. So I'm Louis Chambers from the University of Durham. My question is for Eugenio about the monitoring, the long-term oceanographic monitoring. Did you go back and look through ancient and historic records in benthic foraminifera or ostracods to see these changes in chemistry? Is that something that you've looked at and may record these cycles in the past that may be reflected in present day and future changes?
Actually, it's a really nice question. Thank you for that. But the answer is no. No, we didn't do anything like that. But we will love to do that. No, but no, it's no. We were just focused on the monitoring of the physical, chemical, and biological perturbation in the whole colon water. And we didn't do that. But it's, if you want to come and do that, something like that, you're really welcome.
Stop trying to steal Rich Brown's student. No, they're doing some really nice work, actually. So Ryan Bailey, who's here, who's also working with Dr. Rich Brown, they're carrying on some work that was started by our geo interns 3 years ago, and they're looking at the explosive deposits and trying to identify how many events there might have been. And I think I'm right in saying, well, perhaps you might be able to give us a quick summary, Ryan, of why you're here and why you're following up on that work.
Yeah, so back in 2021, we started this with GeoTenerife, and one of the things that we identified was there's actually a lot of like pumice deposits and deposits from explosive eruptions that hadn't yet been documented very well. So part of what I'm doing is trying to bring that work together that has been done over the last few years with GeoTenerife, and then bring together the work done in the literature by like Pablo Harris, his recent work, and trying to draw it all together and get more of a complete stratigraphy of the explosive eruptions. And as we found over the last sort of week and a half, as it's quite complicated, and yeah, it's going to be a good month of trying to bring all the work together and try to get a complete stratigraphy, which draws a lot of research from GeoTenerife and literature and what we're doing now all together into one sort of almost complete, hopefully, stratigraphy of explosive eruptions on Tenerife. Yeah.
Completing that jigsaw.
Yeah, a big jigsaw puzzle it is.
Lovely, thank you. I think, spoiler alert, there've been more than 20, they think. And this is important to know, and part of our work as well is to try to preserve some of our landscapes here because they are under threat from galloping development at times. Sometimes we develop in a way here that is unsustainable and puts pressure in a lot of ways on the island. And one of the areas that we're working a lot on and that our students here have been working on is in Puertito de Adeje. And I know, Sergio, you're working at the university on this as well, which is really exciting because we have a complete record from La Caleta to Puertito Adeje of 300 years of explosive volcanology of the most ancient type. And it's unique. It's like an open book. And if we simply dedicate ourselves to building hotels and destroying all of this, we might not have the opportunity to study what the past was like and build resilience to possible events in the future. If we don't know how many there have been, if we can't do this study, then we can't build resilience. Other than the fact that obviously it's a beautiful place and residents have a right to access their coast and enjoy their coast as they have done for generations. Anyway, plug over. Any more questions from the floor? Sam, you have a question?
If there isn't any leading ones from the audience. This is, I guess, a brief run for each of our speakers. Both of these events from El Hierro and La Palma presented something very, very unique and very new for the Canary Islands that hadn't been seen, at least on more recent historical timescales. Is there one piece of knowledge or one piece of data that, you know, if you could have had that beforehand, that would have made things so much more clearer or would have helped you for, you know, your interpretations now? Is there one thing in particular that maybe could have helped out in that event? And I guess that goes out to everybody, but maybe start with Omera. Is there one data set or, you know, one particular piece of knowledge that would have been more useful before these eruptions, particularly for La Palma?
Yes, for example, from the atmospheric point of view, we missed some instrumentation related with wind profilers. Yes, it's crucial to know the vertical, to have information about the vertical distribution of wind, because with this information we can combine this information with the total column information, and we have a very clear idea, and together with vertical profile, have a very clear idea about the transport. Also, there are other kind of instrumentation like vertical profile, but they are scanned with different angles, so you have information about the profile, the plume, in real time. So this kind of information, I think, that provide a more complete view about the plume. And for us, for the atmospheric point of view, is more or less we need to complete the input information for a chemical transport model. At least at the end, we have to gather all the information, all the best information to fit the chemical transport model. So I think that's all.
Thank you very much indeed.
Okay. Well, we can carry that on with well, during the coffee break, I guess, because we now have coffee. That is the best news that we have. So if we just want to thank all of our speakers from this morning once again.
Thank you, everybody.